In this lesson, we're going to take a look at different forms of a parabola. We've talked actually about 3 of them, so we'll look at all 3, but we want to do some warm-up first. So we've been given an equation that happens to be in standard form. It is y is equal to x squared minus 2x minus 35, and we have to figure out first the zeros, then the axis of symmetry, and finally what the vertex is going to be. So given this particular parabola, we know that we have to first put this equation into vertex form, which means, or sorry, into factor form. So we have to actually factor it. So we have an equation that says y is equal to x squared minus 2x minus 35. So that means that we're looking for two numbers. And again, those numbers have to multiply to negative 35, and they have to add to negative 2. Okay? So if 1 and negative 35 would give me negative 34. Negative 35 is not divisible evenly by 2, or by 3, or by 4, so it is divisible by 5 evenly. So 5 times negative 7 would give me negative 35, and when I add those two numbers together, it does in fact give me negative 2. So the factored form of this is going to be x plus 5, x minus 7, okay, because these numbers meet the criteria that we're looking for. So now that we have the equation in factored form, because we always have to get the factored form before we can figure out the zeros, we can determine that the zeros are going to be right here. So the zeros are actually negative 5 and positive 7. Okay, so we've just done the first piece. We've determined what the zeros are for this particular equation. So now let's determine what the axis of symmetry is going to be. Well, we know that the axis of symmetry is always the midpoint, the average of these two zeros. So since my two zeros are negative 5 and 7, I'm going to add the two zeros together and divide by 2. So negative 5 plus 7 gives me positive 2. Positive 2 divided by 2 is going to give me positive 1. So my axis of symmetry is when x is equal to positive 1. Okay, so the equation of the axis of symmetry is when x equals positive 1. So now I have to determine my vertex. Well, my vertex means that I have to substitute into the original equation what the x value is equal to. So the original equation says that y is equal to x squared minus 2x minus 35. So I'm going to substitute in my value for my axis of symmetry into that equation. And I've already determined that the value of x is 1, so I'm going to do 1 squared minus 2 times 1 minus 35. So if I go through with my rules of Bedmas, I get 1 minus 2 minus 35. So if I go through, I'm going to do 1 minus 2 minus 35. It shows me that the y value is going to be equal to negative 36. And so that means that the vertex, now that I have both an x-coordinate and a y-coordinate for this point, the vertex is actually going to be at point 1, negative 36.